Welcome to Global Virtue School. Students, this is your first year chemistry class. I am Dr. Jalmano and the topic for today's discussion is from chapter 1 Stoichiometry, and the topic name is also Stoichiometry. So we are going to discuss the concept of Stoichiometry. What actually is the Stoichiometry? Students, stoichiometry, this is very important to understand because our next upcoming topic like mole, Avogadro's number, limiting, non-limiting reactants and yields, these you can understand if you have the understanding of the stoichiometry. Basically, stoichiometry is the Greek word, and this is the combination of two words like stoichion means element and metron means measuring. So measuring the element in the form of mass, in the form of moles, in the form of Avogadro's number, in the form of like molar volume. So concept of stoichiometry, to understand this, it's so much important you can't imagine even. We have a lot of calculations, we have a lot of questions that we can't solve without the concept of stoichiometry. And as I already told you that your upcoming exam will be based on SLOs, students learning outcomes. So if you have the understanding of a topic, then you will be able to solve the questions given in your exams. Now I have written the two SLOs that are relevant to the stoichiometry. First one, construct mole ratios from balanced chemical equation for use as conveyor factor in stoichiometric problems. And second, perform stoichiometric calculation with balanced chemical equation using moles, representative particles means Avogadro's number, mass and volume of gas at standard temperature and pressure. These two SLOs you can't understand without understanding the stoichiometry, and even these SLOs you will be able to clearly understand these SLOs when you have the concept of stoichiometry plus the concept of mole and Avogadro's number and molar volume. So to understand this SLO, you have to clear the concept of 3 to 4 topics, and you can clear your topic from any book. There is nothing bound for the book, so you can go for any textbook, any book, and even you can learn this from some video lectures. So the basic important key is that you have the thoroughly understanding of the particular topic. Before going into the detail of stoichiometry, students, I understand that you must have the knowledge of balanced chemical equation. You have already knowledge about the balanced chemical equation, but now I am just recalling for you that what is balanced chemical equation, what are the non-balanced chemical equation. Balance means something like balance on one side and the other side. Now I have the example in front of you like formation of water like this H2O. This is with the help of hydrogen and oxygen. So do you think this equation in which these are reactants and water is the product, is this a balanced chemical equation? No, according to me this is not balanced chemical equation. Balanced chemical equation is the equation in which number of atoms on reactant sides are equal to the number of atoms on the product side. You can see in this there are 2 hydrogen on the reactant side and 2 oxygen on the product side, and in product there are 2 hydrogen. So hydrogen is balanced in this case, but there is 1 oxygen. So oxygen is not balanced. So make this balance, we have to add some number. Like if we balance this oxygen, to make it double we have to write the 2, but in this case now hydrogen is not balanced now because now this will be the 4 and in this side this is the 2 hydrogen, so we have to add the 2 for hydrogen. Now this equation is balanced. How? There are 4 hydrogen atoms, 2 oxygen atoms, and in this again 4 hydrogen atoms and 2 oxygen atoms. So oxygen, hydrogen on product side are equal, oxygen and hydrogen on the reactant side. So this is a balanced chemical equation. So balanced chemical equation means number of atoms on reactant side should be equal to the number of atoms on the product side. Now I have another example for you. Formation of carbon dioxide with the help of carbon and oxygen. In this case you can see there is 1 carbon on reactant side, 2 oxygen on product side, reactor side, so also 1 carbon and 2 oxygen on the product side. So this equation is a balanced chemical equation. Here are a few more examples for you. Formation of sodium chloride. This formed with the help of sodium and chlorine. In this case, you can see this is not a balanced chemical equation because there is one sodium and in this side one sodium. This is balanced, but there are 2 chlorine atoms and there is 1 chlorine. So chlorine is not balanced, means equation is not balanced. So to make this equation balanced, we have to write that 2 with sodium and 2 with sodium chloride. Now this equation is balanced. How? Because there are 2 sodium atoms in this side, 2 chlorine atoms in this side, so also 2 sodium in this side and 2 chlorine on this side. So now this equation is balanced. So you have lot of examples in any book, the equation is balanced or not balanced. Stoichiometry basically is based on the balanced chemical equation. So keep this in your mind that whenever you talk about the stoichiometry, then you have the equation balanced chemical equation. So now come to the topic, that is stoichiometry. So if you have given the question what is stoichiometry, then you have to define it. What is stoichiometry? So its definition is, this is the study of relative amount of substance involved in balanced chemical reaction or balanced chemical equation. Reaction equation means same. So relative amounts of substance means, this substance means both reactants, we are talking about both reactants and the products. So when you have balanced chemical equation and we are talking about relative amounts of reactant and products in balanced chemical equation, then this study is called the stoichiometry. Now I have 2 examples for you, formation of water and formation of ammonia. So you can see this is the balanced chemical equation. 2 moles of hydrogen reacts with 1 mole of oxygen to form 2 moles of water. So talking about these relative amounts, like 2 moles of hydrogen, 1 mole of oxygen, when there is nothing, it means a 1 mole, and 2 moles of water. So these 2 moles, 1 mole and these 2 moles, they are relative amounts in balanced chemical equation, and this study is called stoichiometry. Similarly, in ammonia formation, this requires 1 mole of nitrogen, 3 moles of hydrogen, it gives 2 moles of ammonia. So these relative amounts in balanced chemical equation. So you have noticed these equations are balanced. So in this balanced chemical equation, then this study is called the stoichiometry. Hopefully this is clear for you. Stoichiometry can also be defined as when we take the quantity according to balanced chemical equation, then this is called stoichiometry. So when you have balanced chemical equation, the amounts that are taken according to balanced chemical equation, then this is stoichiometry. For example, this amount of nitrogen 1 mole, hydrogen 3 moles, ammonia 2 moles, then these quantities are according to balanced chemical equation, then this study is called stoichiometry. And these amounts that are according to balanced chemical equation, then these amounts will be called stoichiometric amounts. Of course, like in this example, you can see, you know, a mass of 1 hydrogen from the periodic table is 1 AMU, 1 atomic mass unit. We can also call this 1 mole per gram. So here we have 4 hydrogen. So 1 hydrogen has 4 hydrogen will have the mass 4 gram per mole, for 4 AMU. And oxygen, 1 mass of 1 oxygen atom is like 16 atomic mass unit. So here is its 2 oxygen means 32. 32 plus 6, they give you 36. So again in this product there are 4 hydrogen and there are 2 oxygen. And 2 oxygen means it's 32. Total will be 36. So these amounts, like 4 hydrogen, 4 atomic mass unit or 4 gram per mole of hydrogen and 32 oxygen, that gives you 36. So these amounts are stoichiometric amounts. Similarly, in the next example, nitrogen atomic mass is 14. 14 plus 40, it gives you 28. And 3 hydrogen, and there total 6 hydrogen, and 1 hydrogen has 1, 6 and 1, 6 plus 6. So it gives you 6 and 8, 4, this gives you 34. And in this case, nitrogen is like 1 hydrogen has 14 and 3, it gives you 17, and 17 to multiply, then it gives you 34. So these amounts like 28 mass of nitrogen, 6 mass of hydrogen, that is giving you 34 mass of total ammonia, then these amounts are called stoichiometric amount. So students, you have realized that balanced chemical equation. So equation is balanced. So the amounts in balanced chemical equation, these are stoichiometric amounts, and this study is called the stoichiometry study. So stoichiometry is all around us, like in our daily life as well as in the industrial life. So let's come. We have an example from the daily life. Formation of a sandwich. You know sandwich, like their sandwich means something between two layers. So we have different types of sandwiches, like cheese sandwiches, like kebab sandwiches, like potato and some other sandwiches. So sandwich means two things above and down and one in center. So like formation of cheese sandwiches, it means you need bread and cheese slices. Then they make the sandwiches. For example, you have this bread and you have cheese slice, it is making a sandwich. So according to stoichiometry, is this a stoichiometric amount? No, because in sandwich is using two slices of bread, one above and one below, while we have just write one bread and one cheese slice is okay. So this is not balanced, because number of breads on reactant side is different from the number of bread on the product side. Products have two breads, while reactant side has one bread, but cheese slice is the same on both sides, one. So this is not stoichiometry. So stoichiometry will be when you have two bread slices, one cheese slice, it will make one sandwich, because whole two bread slices are consumed and whole one cheese slice is consumed to make one cheese slice, one sandwich. So this is stoichiometry. So stoichiometry means number of reactant side should be equal to the product side. So total mass on reactant side is equal to the total mass on the product side. So even if you have lot of breads and cheese slices, that the exact quantity that is used in the sandwiches, that will be the stoichiometry. Students, even you can do this experiment in your kitchen. If I gave you 6 bread slices and 3 cheese slices, how many sandwiches you will prepare from out of these quantities? And you also have to tell me if this is, I have given the amounts like 6 breads and 3 cheese slices, either they are stoichiometric amounts or non-stoichiometric amounts. And remember, this stoichiometry means balanced on reactant side and balanced on product side. Stoichiometry is equally important in industry. In industry, like for example, I have just few examples. There are a lot of examples in industrial life. A firework manufacturer. Who is a firework manufacturer? Person that prepare the firecrackers. Firecrackers, you know, usually used in our birthday celebrations or like other celebration, New Year celebrations. So if he has the knowledge of exact calculated amount of the reaction, then he can prepare a controlled firecracker. Why it is necessary? Because if he has not a control on a firecracker, then there may be explosion. So different type of firecrackers, a fire manufacturer must have the knowledge of the stoichiometry. Otherwise, this will be difficult for to prepare firecrackers. So students, hopefully this is clear. Similarly, the engineer must know the relative. This is talking about just one engineer, but there are a lot of work for different engineers. Engineer that is working on some combustion engine, he must know the relative amount of fuel and oxygen. You know, for the combustion of the fuel, there is a need of the oxygen. So if he has a relative amount of fuel and oxygen, then combustion engine, its working will be efficient. Why if we don't have the knowledge of how much fuel is used for how much air and how much air is consumed for fuel burning, then maybe combustion engine efficient may be compromised. So this is very important to know the stoichiometry. Similarly, a chemist is required to use calculated amount of reactants to produce exact amount of product. So if you want to prepare some exact amount of the product, then he must know the exact amount of reactants. For example, if some scientists want to prepare the table salt, like this is the sodium chloride, you know sodium chloride is NaCl. So if he know the exact amount of sodium, if he is going to prepare some exact amount of sodium chloride, he must know the exact amount of the sodium metal and exact amount of the chlorine. Then he will mix and then prepare the sodium chloride. But if we don't have the knowledge of the stoichiometry, then maybe something extra, something limited. So this is important in industrial life, in labs, as well as in the daily life. Students, something you have noticed while doing this calculation, like stoichiometric studies, we assume, we suppose, like we consider 100% reactants are converted into the products. So I have given you the examples, and in the example you have noticed that all of the reactants, 100% reactants, they converted into the product. There is nothing left than reactant. So in stoichiometry, we assume that 100% reactants, they convert into the product. Similarly, you have noticed that there is no side reactions. No side reaction means not as some byproduct, the product that we don't need. So we consider there is no side product. All of the reactants just converted into our desired product. There is no side reaction. Also we consider, and we have noticed that total mass remains conserved. So in if you recall the cheese sandwich slice, like all of the bread and cheese consumes to form the sandwich. There is nothing left in the reactant side. So all the mass remains conserved, just it changes from reactant form to the product form. Similarly, in ammonia formation, you have noticed that 34 total mass of nitrogen and hydrogen, it giving you 34 ammonia. In similarly, in water example, 36 reactants grams given 36 grams of the product. So it means total mass remains conserved, just it changed from one form to the other form. Otherwise, their mass remains conserved. So students, here is the question about like total mass remains conserved. If you recall, which law is applied here? You have learned about the law of conservation of the mass. What is the law of conservation of mass? Law of conservation of mass is mass can neither be created nor destroyed. You can't create the mass, you can't destroy the mass. It just changes from one form to the other form. So if you have asked which law is applied while doing the stoichiometric calculations, so you have to tell law of conservation of mass, and law of conservation of mass is that mass can neither be created nor destroyed. It just changes from one form, any type of the form, to the other, any type of the form. It just changes from one form to the other form, otherwise remains conserved. Just its form changes, but mass remains conserved. So law of conservation of mass is applied while doing stoichiometric calculations. So usually question, students, stoichiometry is important not for its question in the exam. It's important for all upcoming topics. If the question is asked like what is stoichiometry, then you have to define, just define the stoichiometry and give the example. Nothing to write extra. And what is stoichiometric amount, then write the what is stoichiometric amount and with the example. Then question can be give some examples of stoichiometry, then you have to put just examples of the stoichiometry. So whenever the question is asked what is stoichiometry, then you have to define with example, and then when you have given just give example, then you have to quote the example. And I have given you a lot of example in the formification, like formation of water, formation of ammonia, from daily life and from industrial life. So you can, if the question is short response question, you can give 2 to 3 examples. And so this was all about the concept of stoichiometry. So in this lecture you have, hopefully this is clear for you. If you have some question, you can write in the comments. Concept of stoichiometry, and we have discussed its important in daily life as well as in the industrial life. Students, our next topic will be about the mole. So concept of mole is also as important as stoichiometry.